Right. Good afternoon. Today we will discuss 2010 Unit 1 past paper, which is computer programming paper questions. So from 2010 we can consider one by one. Right. In 2010, I already sent you the question numbers. 2010, 23 up to 28. Right. There were some questions. Right. Answer the questions number 23 to 25 using the flow chart in figure 4. Right. So in this figure 4, there's a flow chart given. Question number 23 is, so before you consider the question, first go through with the flow chart initially. Right. So here there's a start symbol. After starting, set required temperature within bracket R to 26 degrees Celsius. Right. So required temperature's value is 26 degree Celsius, which means R 26 degrees Celsius is assigned for the R. Right. This is the meaning of this statement. Right. Set required temperature R to 26 degree Celsius. So that is done. Read current temperature. So you are going to read the current temperature. It might be a room temperature. So you are going to read a temperature. Then is C greater than R? So C is the current temperature. R is your required temperature. You are comparing it. Is C greater than R? Question mark, which means you are going to check a condition. For this particular condition, there are two options available, yes and no. So if you are having yes and no, it might be a selection, not must be. It might be a selection, because in iteration or repetition also you will have yes, no. Right. So when we go through with this flow chart, whether it is yes or no, if it is yes, display cold. So if it is no, display cold. If it is yes, display hot. Then end, which means there is no any iteration. So the summary is, this is a simple selection. You are having yes and no. This is a simple selection flow chart. Right. So initially we have gone through with this flow chart. Now I will consider the questions one by one. What are the outputs of the flow chart if the current temperature is 28 degrees Celsius, 27 degrees Celsius, 26 degrees Celsius? So in this condition, we have to check C greater than R. As I said earlier, R is a fixed value, which is 26 degrees Celsius. So initially you are providing 28. So 28 greater than 26, it is yes. So you can say hot. Right. So the first option must be hot. So depending on that result, you can remove first answer. Why? The results will be yes. Second input 27 degrees Celsius. So here I will erase this one and provide 27. 27 greater than 26, that is also yes. So display hot. Depending on that result or based on that result, we can say second option also wrong. Right? Now, my third input, which is 26. 26 greater than 26. That is false, which means no. You will have the result cold. So hot, hot, cold. The answer option is third option. That is question number 23 in 2010 O-level paper. Question number 24. Which of the following control constructs are required to convert the flow chart into a computer program? As I said earlier, in this flow chart, sequence is there. Sequence is the one step by step. So that is there. Selection, we already identified, it is a simple selection. So you will have yes and no. There's no any iteration. So no any iteration. So straight away you can remove D, C. In this selection, there will be two parts. Yes is there, no is there. That's why you need if, then, else construct. This is false. If, then only, not enough. So B only is your answer option, second answer. That is question number 24. Question number 25. Which of the following data types is suitable for variables C and R in the above flow chart? Right? So this is very straightforward question, but it would be better if we have integer, right? So then you will get confused. Which is the answer? Integer or real? Why? It's a temperature. So temperature, sorry, we can't say it would be exactly 26, exactly 27. We can't say. It might be 27.3. It might be 27.45. Likewise. So the most appropriate data type would be which one? Real. Second answer option. Right? When you are having integer and real in your answer sheet, answer options, you must choose real because temperatures always or most of the times would be in fractions. That's why it is real. So that's the end of question number 25. Question number 26. Which of the following statement is incorrect regarding a variable used in a computer program? Incorrect. A variable has a name. Definitely, a variable will have a name. Right? That is fine. A variable refers to one or many memory locations. Right. Statement 3, a variable has a data type. Definitely a variable will have data type. The value of a variable remains unchanged. Variable, we already studied that the value of the variable will be changed according to our program. So we can't say it is unchanged. A variable refers to one or many memory locations. In computer programming, a variable can be referred in n number of locations, whatever we need, 2 or 3 or 4 or 5, right? So no any issues. So that's why, right? So the answer option will be fourth answer option. Question number 27. Which of the following represents the correct order of precedence of the arithmetic operators from left to right? Right? From left to right, you have to say the correct order of precedence. You have addition, multiplication, equal sign is there, addition, multiplication, subtraction, multiplication, addition, division, multiplication, division, addition, right? So there's a clear statement, order of precedence. After the bracket, you have to consider the power. So power is not there. That's why our next level would be multiplication or division, right? So multiplication or division, according to that theory, this is wrong, this is also wrong. Why? After addition, we are having multiplication. After addition, we are having multiplication. Here we are having multiplication, that is fine. Then we are having addition, that is also fine. But after the addition, we are having division, that is wrong. That's why this is false. So multiplication, division, addition. So the answer option is fourth answer option. That's the end of question number 3 of 2010. Question number 28. Consider the following pseudocode. Begin input number 1. Right? My recommendation is always convert the phrases into symbolic format. So input number 1, you can say N1. It is very simple. Input number 2, you may write N2. Result equal number 1 divided by number 2. Right? So result equal N1 divided by N2. Output result. So output number 2, output number 1. So here you have to be sure that what is the order they have asked. They asked that the order is output result first. So N1 divided by N2 value will be your first answer. So here your order is in reverse. So n1 divided by n2, then number 2, then number 1. So in your answer, the order is result n1, sorry, n2, comma n1. This is your order, right? Then you have to compare each and every answer options and correct it and choose the correct answer. So here, the first one, which one? This one must be the result came from n1 divided by n2. n2 is this one, n2 is this one, n2 is this one, right? So here this is n2, this is n1, right? But the order is n1 divided by n2, right? So there are so many confusions, right? So 3 divided by 12, 3 divided by 12, which is 1/4. So that is wrong, right? 10 divided by 2, which is 5. That is right. 2 divided by 10, that is 1/5. That is wrong. 2 divided by 8, 1/4. That is also wrong. So your answer option will be second answer option. Like, it's a very simple and straightforward question, but there's a little bit confusion of the order. Like, this order is one confusion, and then inputs are in another confusion. So you have to convert these lines into symbolic format, then you can find the answer easily. That is the end of 2010 paper, right? Right. Now we will discuss 2011 paper. There are question number 22 up to 27, right? Consider the given flowchart to answer questions 22 and 23, right? So 22nd question and 23rd question, you have to consider this flowchart. Start. Set counter to 0, right? So before considering your question, you have to convert this one to equations. So counter equal 0. Set total to 0. So total equal 0. Get a number num, right? So you can simply convert it as read num, right? The entire phrase can be written in shortened form, read num. Add num to total. So add num to total means total equal total plus num. But this procedure we already studied in our class. There were more than enough practice questions we have done. So there's no worries. Total equal total plus num. Add 1 to counter. Right? So counter equal counter plus 1. Right? Is counter less than 3? Is counter less than 3? Right? So these are the conversions of the flow chart which I have done to do the questions easily. Right? Which of the following is correct regarding the flow chart? So they are asking some a question based on this flow chart execution. Right? First go through with the answers. It repeats more than 3 times. It stops when 3 is entered for a num. It displays the total when the counter is 3. It gets 4 number from the user. Now you can realize the usage of trace table. Right? So the trace table concept was already discussed in our class. Right? So you can draw the trace table as soon as possible, or you can do it manually. Manually, when you are doing, it will be more difficult. So you can draw a trace table. Right? First, I will do it manually. It repeats more than 3 times. Right? So you are reading a number here. You are adding the number to the total. Counter is increased by 1. Already the counter is 0. When you are inserting a number, the counter will be increased by 1 after the execution of total equal total plus num. Right? When we do the total equal total plus num, after that execution, counter will be increased by 1, counter equal counter plus 1. So in this case, initially counter was 0. After the first input, counter will be 1. So here it will be 1. Right? 1 less than 3. Yes. So it will go back. Right? When it is go back, 1 iteration. Again input the number. Total equal total plus num. Counter equal count plus 1. Already the value of counter is 1. 1 plus 1. Now it is 2. Right? So here it is 2. 2 less than 3, it will go back. So second time. Then it will input the number. Total equal total plus num. Counter equal count plus 1. So counter already 2. 2 plus 1. Now the counter is 3. 3 less than 3, false. Display total n. Right? Just observe, before the condition checked, already 1 input is there. After condition checked, there will be 2 times iteration. So altogether, how many? 3. Right? It repeats more than 3 times. 3 is fine, but not more than. So more than, it is wrong. It stops when 3 is entered for num. There's no relationship between iteration, this termination of the iteration. Why? The condition is based on counter, not based on num, right? Not based on num. Here, the condition or the iteration is depending on counter, not in num. So that is also wrong. It displays the total when the counter is 3. Here, when counter is equal to 3, it will be 3 less than 3, no display total. So that is fine. It gets 4 numbers from the user. No. Initially 1 number, then 2 times go back the iteration. So altogether 3. Right? So in your exam paper, in your past paper book, underline this one and then put it is false and write 3. More than 3, that is wrong. Only 3. 3 times only. Right? So for the question number 22, the answer option is third answer option. Right. So that's the end of question number 22. Question number 23. Which of the following can be used to replace? We can use this one. Okay. Which of the following can be used to replace add num to total? Here, add num to total. Total equal total plus num. Which one? Third option. So when we do it initially, we can just use it in our question paper. Right? So total equal total plus num. That's the end of question number 23. Question number 24. Which of the following statement is correct regarding control structures used in algorithm? Control structures, they are asking. Statement 1. Statement or statements within an if-then construct is executed when the condition is false. Right? When there is the if-then statement, they are saying if the condition is false, it will be executed. That is false. When it will be executed? When the condition is true, then the condition will be executed. Right? So the condition is true, then the statements will be executed. That's why first answer option is wrong. For next loop can be used when the number of repetitions is known in advance. Already we discussed this type of question in our class. For next loop, we have to provide the initial value, ending value, number of repetitions, and etc. Every conditions in advance. So that is true. If then construct cannot be used within a for next loop. If then is a selection. For next loop is an iteration. Iteration, selection inside iteration, inside iteration inside selection. Those two types of questions we already discussed in our class, right? So here, if then construct cannot be used, right? That is false. Can be used, right? I gave you two questions, right? You can look at your exercise book and find out those examples. Selection inside iteration, iteration inside selection, right? If then construct cannot be nested. If then construct cannot be nested, right? Can be nested. That's why this is also wrong, right? So the answer option is second answer option. Please refer your exercise book. On that exercise book, I gave you enough questions for your practice, right? Question number 25. Consider the following statements regarding operators in a programming language, right? We already studied about the operators. A. An operator performs an operation on one or more variables, right? An operator performs an operation on one or more variables. Can. So it is true. An expression may have more than one operator. In a single expression, we may have more than one operator, addition, division, subtraction, everything. So that is also right. Comparison operators compare two expressions. That is also true. We can compare two expressions by using comparison operators. That one also we discussed in our class. So the answer option will be fourth answer option. Right? Question number 26. Consider the following types of computer programming languages: machine languages, assembly languages, high-level languages. I already explained these things in our class, which I already told you. There are two types of programming languages: low-level language, high-level language. Inside the low-level language, we discussed machine language and assembly language. Next category is high-level language. In low-level language, the initial language was machine language, then assembly language was invented, right? So assembly language was formed after the machine language, then high-level language. So the order is machine language, assembly language, high-level language. What they ask is, which of the following shows the order of generations of the above programming languages in ascending order, right? So ascending order, which is first machine language, then assembly language, then high-level language. So the order is first one, right? They ask you in the ascending order. That is the end of question number 26. Question number 27. Which of the following statement is correct regarding a compiler and interpreter? Right? Compiler and interpreter, we already discussed in our class. Now we can consider the questions and the answer options. So they are comparing the compiler and interpreter. An interpreter translates all statements into machine language instructions before the program execution. Right? They are saying an interpreter translates all statements into machine language. Right? All statements. No, that is wrong. So that is not correct. A compiler translates each statement into machine language instructions one at a time during the program execution. That is also wrong. Compiler translates entire program. But here they are saying each statement. That is wrong. A compiler needs an interpreter for program execution. That is also wrong. An interpreter translates each statement into machine language instructions one at a time during the program execution. One at a time. That is the correct statement. Only one line at a time. So question number 27, the answer option is fourth answer option. You can refer your notes in your exercise book. Right? So that's the end of question number 27 and also the end of paper 2011 in programming. Right. Now we will discuss 2012 paper. In 2012, there were 3 questions, 29, 30, 31. Right. Initially, I will consider one by one. Question number 29. What is the result after evaluation of the following expression? Consider the operator procedures of programming languages. Right? So you are going to consider the operator procedures of programming languages. So you can see there's a multiplication, addition, multiplication, subtraction. So from left to right, you have to consider one by one. Your priority is multiplication and division first. So first you have to do the multiplication. So 5 into 3. So 5 into 3, which is 15, plus 1 into 5, 5, minus 1. Why? We have to do this multiplication first, then this multiplication. So 15 plus 5, that is 20. 20 minus 1 is equal to 19. Right? So your answer is first answer option. That is question number 29. Question number 30. Consider the following logical expressions. There are three logical expressions given. Which of the following represents the correct outcome of the expressions A, B and C respectively? Right? So you have to consider the logical expression one by one and find out the result. So I will consider one by one. 23 greater than 14, which is true. And 11 greater than 8, that is also true. True and true. In an AND gate, true and true will result true. So all are fine. Second, 23 less than 40, that is false. Or 11 greater than 8, that is true. False or true. It is an OR gate. OR gate. If we want to get the results as true, at least one input must be true. Here there's one input true. That's why true, false, it will provide you true. Right? So second option will be true. So this is false. So you can remove this one. This is false. You can remove this one. Other two, fine. Not within bracket 23 greater than 40. 23 greater than 14. So initially you had to do the bracket. 23 greater than 14, that is true. Right? For the true, when we take not or when we apply not, that will be false. So the answer option will be third answer option. That is the end of question number 30. When you note like this, you can get an easy way to find out the answer, right? Question number 31. So 31. What is the expected output of the following pseudocode segment? So n is equal to 1, do while n less than 5, print n equal n plus 1 loop. So you can write the, or you can find out the answer as soon as possible. While n less than 5, n is equal to 1. 1 less than 5, true. So print n, it will be 1. So depending on that answer, you can remove this one and this one. Then n equal n plus 1, that is 2. 2 less than 5. 2 less than 5, that is true. Print n, the new value of n will be 2. N equal n plus 1, right? So n equal n plus 1, the current value of n is 2, 2 plus 1, it is 3. It will go back here. So 3 less than 5, true. Print n, 3. N equal n plus 1, 3 plus 1, which is 4. It will go back here. 4 less than 5, true. Print n, 4. right? For n equal n plus 1, 4 plus 1, which is 5. It will go back here. The value of n will be 5. 5 less than 5, it is false. So it will exit from the loop. They ask you the expected output, right? So the expected output means you have to consider print n outputs. 1, 2, 3, 4. First answer option, right? That is the answer for question number 31, and also the end of 2012 ICT paper in unit 1 grade 11, right? If you are having any doubts, you can ask. Right. So that's the end of 2012 paper.